University. We're very happy to host today Dr. Daniel Mietchen from the University of Virginia. Daniel is going to introduce himself in a second, and he's going to talk to you today about Wikidata Medicine and show you some cool stuff. So without further ado, Daniel, would you like to introduce yourself to the students?
Yeah, well, I'm a biophysicist by training and have actually studied medicine for 2 years and then gave up because I did it in parallel to biophysics, and I found biophysics slightly more attractive, but I still like medicine. And now I'm a data scientist at the University of Virginia, where I actually have the privilege of not being confined to traditional disciplinary boundaries. So I can do medicine one day and I do biophysics the other, and then something else yet the next day. That's very nice. And Wikidata is something I mostly do in my spare time. And that fits with that pattern. It has information about cultural heritage, about sports, about all sorts of people involved in any of that. And it has science, it has medicine, and many other things. And today I want to show you, well, just some glimpses of that. I have given it mostly medical focus, but I've included a few examples from other areas. The slides are online. It's essentially just one slide. It's a wiki page. I also just tweeted it, and I encourage you to follow at your own pace. I also set up an Etherpad, which is linked from the page. And so you can post questions in there or comments. And actually, you can interrupt me anytime because this is not, let's say, a scripted lecture. This is meant to be to facilitate your understanding of the matter. And the understanding is most served if a question is dealt with when it crosses your mind rather than half an hour later. And so, yeah, I'll start by sharing my screen, and then hopefully we can just do things together. Okay.
Daniel, can you share the link in the chat so we can see it?
I did that like
oh, you did
20 minutes ago.
Oh, I see. Let me just open it and see if I can share it with the students in an easy way.
Yeah, the easiest would be to go to my Twitter because it's linked from there. Or
so let me just very quickly send it to my students through our forum.
Yes.
And then they can have it.
And in the meantime, I am starting to share my screen. So now you should see me like twice or something. I see myself right now.
Well,
yeah,
yes. Now that the screen is shared.
Beautiful multi-sharing screen.
Yes.
I just took a picture of that. It's just too beautiful.
Can you click hide at the bottom?
Oh, no, not necessarily. Oh, yeah, here we go. Hide. I'm hiding. Okay. Hiding is not in my nature, but yes.
But you'll need to kind of make it bigger because we can't see it.
Yes, I remember that from last time, and this will make the experience quite awkward for me. So I'm now at 250% for me.
Okay.
Is that good for you?
Yes, it's much better.
Still not good. Okay.
No, it's much better.
So okay, we'll see. So yeah. So this is the course here. It's a normal project page on Wikidata, actually a subpage of Wiki Project Medicine. And if you scroll down, you have a link to the Etherpad. So an Etherpad is something that anyone can edit. You don't need to log in. There you see a link back to the wiki page, a link to my tweet with the link, and also a link to this live stream that we're on right now. If anyone is following remotely for any reason, you can join us this way. And then basically the things I plan to talk about are lined out on this page. But as I said, you can interrupt me anytime, and then we can diverge into any other topic that makes sense. And I hope Shani can steer us in the process. So let me start by just explaining a little bit about this Wiki Project Medicine.
Can you actually start by telling the students a bit more about what you do as a scientist and like how you got into Wiki in the first place? Just a short background on you.
Okay. My background, as I said, I'm a biophysicist, and I discovered Wikipedia while I was doing my PhD back in the early 2000s. Initially, I discovered it because I noticed there's this website that has content in multiple languages. And since I did my PhD in physics, languages were not other than English and were basically not relevant, but I like languages. And so in order to deflect myself and have some relaxation, I actually read those Wikipedia articles in multiple languages, like articles on Berlin or so. They would have like 4 languages, 5 languages back at the time. And so that's the kind of article I would read when I had a break. And at some point, I discovered you can actually edit this page. It took me a while. It wasn't initially obvious that even though the edit button has always been there in some way, I initially didn't pay much attention to it. And then, so I just started to fix a few commas here and there and things like that. And then at some point I discovered, oh, they do not just have like information about cities and stuff, but also about science, which is when they got me. Initially I edited just whenever I was, basically as part of my normal information gathering workflow. If I noticed something that I learned, I was checking whether Wiki knew about it already. Sometimes it did, and it knew much more. And then I sometimes ended up in the Wiki rabbit hole, just reading up on the thing that I just began to learn. And sometimes I noticed, oh, they don't have much. And so I contributed the little bits that I just learned there, because then I would know, oh, it's there. I knew it's in Wikipedia, because if I put it somewhere else, especially in a non-public space, I would always need to remember where I put it. And having it in Wikipedia makes it very simple, because that's, at least by now, it's the default mode for many to start searching. And on that basis, when Wikidata came around, I was very attentive to it. I was kind of actually anticipating it. So Wikidata tried to solve one problem initially, that an article like Berlin or Tel Aviv or so might exist in like 200 languages. And each of these different language versions would link to all of the others. So we were essentially curating the same kind of information 200 times, which is not very efficient. And so one of the first roles of Wikidata was to bundle that. So instead of every Wikipedia language version of the same article linking to every other language version of that article, they would all link to Wikidata, so that is one link to curate per language. And then Wikidata would link back to all the Wikipedia languages. And so Wikidata then curates all the 200 links, but every individual language just creates one link, essentially. And on that basis, we then had this large collection of concepts, like the concept of Berlin or Tel Aviv or medicine or anything like that. And initially, they were not annotated in any semantic way. But once we had this collection, we could start saying, oh, Tel Aviv is actually the capital of Israel, or medicine is a branch of academia, or something like this. And that's where the semantic web came in. And at that time when Wikidata started, I did not know much about it. So actually Wikidata helped me. Again, it's all about me engaging, because it helps me learn. Wikidata helped me learn about the semantic web, which had been a rather abstract concept for me. And essentially, Wikidata is the edit button to the semantic web, because it is compatible with the semantic web. It is publicly accessible. It makes it easy to contribute. It also makes it easier than other places to actually pull things out, especially if you're not a specialist. And it's more collaborative. Many of the other semantic web projects, they're like, it's a smaller team and not as open to collaboration. Yeah, so, and of course, since I had been spending like more than a decade on the interface between science and Wikipedia and the broader Wikimedia ecosystem already, then in Wikidata, my focus was and still is the interface to science. And here I'm using the term science in the broader sense, like the Latin sense, which is also still used in German, like Wissenschaft. and not in the narrow sense of English where they are restricted to natural sciences. And so in that broader sense, medicine is actually included, and so is engineering, and so are all the arts and humanities and social sciences. And I'm interested at activities at the interface between what you, could also be called scholarship and Wikimedia. Is that good enough as an introduction?
This is awesome. Thank you so much. Any questions before Daniel delves into the actual material that we wanted to kind of show to you today? Okay, feel free to barge in, and also this is a good time maybe to say we are streaming also on YouTube. So if you have questions, you can log in either to directly to StreamYard and ask questions in the chat, or like Jonathan just did, and or you can simply ask here and we'll convey it to Daniel. Okay,
Yeah,
Daniel?
I'll not monitor the StreamYard chat. I'll see what you will see. What I see. I'm sharing my screen, and so yeah.
Yes,
But
I'll questions if we have any.
Yeah, okay. I also have the Etherpad. I have another machine right next to me where I can see if something's on the Etherpad, but still, my focus will be on this screen. Okay, let's get started. So I chose. Okay, here's the Wikidata entry for Tel Aviv University, for instance. And now I'm not logged in. This is because when I'm editing myself, lots of the things you would see are highly personalized, localized, and things like that. So that might be confusing. That's why here I chose to use it, not to be logged in. And you see, much like on Wikipedia, the thing has a title. Unlike Wikipedia, it also comes with an identifier, which happens to be the same that is in the URL. And that's actually already a key element of Wikidata. So everything having a URL is a key characteristic of the semantic web. That is a unique persistent identifier, which means that as long as you're on the web and you're talking about this particular thing, then everybody knows how to get there. Actually, the formal way would be, instead of the wiki, to put an entity here, and then a machine can go to one place to see the information, and the human can go to another place, which would then be the wiki part. But that's maybe not as relevant. Then yes, it's very relevant that we have multiple languages here. So a few are being shown by default. And then if you click the all entered languages, you would see many more. We don't have time for that. Then
the students already they've had 2 sessions on how Wikidata is constructed at the very beginning of queries. So you can kind of skip the
I can kind of skip that. Okay, good. What I want to do is just some round tripping between. Also, you've done this from going from Wikipedia to Wikidata as well, right? Every Wikipedia page has a link to the Wikidata item. So in English, it's on the left-hand side, and Hebrew and Arabic on the right-hand side. And so you can go from Wikidata to Wikipedia and back, and also Wikidata knows about all the other languages. So if for any reason you want to see it in Catalan, okay, here's Catalan, right? And initially, when you're looking at this, it all looks more or less like a form field, rather boring. But since this is linked data, it means that we can bring it all together, which the Spark queries will do later on. Okay, so enough of that. So a practical example. Let me close a few tabs here. So a practical example is this thing here. Some text, and then we have a table. Actually, most of the table I can't read because it's largely in Hebrew, and my Hebrew is very bad. It's not entirely zero, but yeah, nearly so. And what I have done here, this is actually very bad to see on this small screen, a table that is based on a Spark query. So you have had Spark queries before. So the important thing to know here is just that, well, let me briefly walk you through. An item that is linked to Tel Aviv University in some way, or it's linked to something that is part of Tel Aviv University. And for that item, I want to assure that they are human and that they have some statements. And I limit that to a list of maximum of 3,000 entries. So that's how this table got constructed. You see, currently it has 2,376 entries, and that is 2,376 people for which Wikidata knows that they have some connection to the University of Tel Aviv. And the table is sorted by the number of statements. So the Wikidata items with the most statements are these at the very bottom, and the Wikidata items with the least statements are at the very top. And so we can have a look at some of those. For chess players, yeah, you notice the top 3 here are chess players. This is not entirely accidental. That is because they have the chess ratings. Yeah, here, ELO ratings, point in time, all of that, essentially their entire life as a chess player is represented in this data, and you have lots and lots of statements, which may or may not be useful in some context, but for, as long as you care about chess, it's very useful. Then here, this person is a chess player and a surgeon, so we're already venturing into medicine. So let's have a look at this one. And it has an image. Where's the surgeon? Chess player, surgeon. There's not much more. Grandmaster, international master. So again, the focus is on the chess in terms of what they say here, but we could also look at them from a medical perspective. And it's important here really to know that such tables are useful when you want to curate information. And the table is generated automatically, so I did not sit down and write those 2,000 lines. I just wrote this very short Sparker query, and then there is a bot, which you can see if you look at the page history for this. There is a bot that comes in roughly once a day and updates the list if any of the results of the Sparker query have changed. So it runs the Sparker query once a day and checks whether the content of the results matches the content of the table as it is, and if not, it updates the table. It's very convenient. And that's one way of using the structured data. And you see some of those things, they are quite different things, and I can actually choose which of the data that is on the items is actually displayed in this table. So right now in this table, we don't have all the chess ratings, even though they were present on that item. So, which means I can filter the information. I can also combine different pieces of information. And we will then, in the later parts of the talk, we will see a number of other examples for that. Okay, so back to Wiki Project Medicine. So Wiki Project is something that allows people to collaborate. So the wikis are an online platform. So most of the collaboration on there takes place just like Wikipedia in a way that the individual people involved do not know each other personally, or at least not necessarily, or not initially. And the main mode of collaboration is actually online. And in order to coordinate for that, you have your forum for your course. And in the wiki context, we have wiki projects, which is a page that sits in a different namespace. So here we have the Wikidata namespace. All the normal content on Wikidata is in the item namespace. We have properties and lexemes as well. And so this is the homepage for Wiki Project Medicine, which has a number of subpages that I will not go into too much. But it has goals. One is to manage the site links to medical topics. That's similar to the thing I've explained for Berlin already. So the concept of medicine or surgery or anything like that, any such topic that might have a Wikipedia article. If those Wikipedia articles exist in multiple languages, then Wikidata helps manage the links between them. And just like you see it here, so this Wiki Project Medicine exists in multiple languages as well. And so you can hop from here to any of those. That's one of the things. Then it manages those identifiers. So for instance, Ebola virus disease has the identifier Q51993. And that is also, then it has the statement that in the disease ontology database, it has the ID 4325. Let's just verify that. Yes, so it's an exact match to the disease ontology ID, which means with that identifier, as long as I know this identifier in the disease ontology, I click on this and I should end up on a page about Ebola fever in the disease ontology. So this mapping between what a term means in different databases is actually a very important thing, especially because Wikidata is cross-disciplinary. Most databases have a very clear focus. Like in PubMed, you only find medicine, mostly medical articles. You have lots of articles, but they all essentially have some sort of a link to medicine. You will have a hard time finding detailed coverage of ancient Egypt literature or anything like that. Wikidata has entries about all sorts of subjects. So you can find things about ancient Egypt, you can find things about sports, about TV shows, whatever, and medicine, and geography, and astronomy. And so it is an important part of the landscape that links those databases together. And you can use actually Wikidata to filter. So, for instance, if you want to find out about biological effects of some chemicals, you filter for things that have identifiers in some chemical databases, and then for those things that have identifiers in databases that have information about biological effects, things like that. Okay, another thing that Wiki Project Medicine engages in is the ontology. So by this, we mean it's links between controlled vocabularies or between controlled terms. So for instance, surgery is a field, a subfield of medicine, essentially. So these things can be all arranged and hierarchically ordered, and doing this in a consistent way is something that Wiki Project Medicine engages in. Then those things need to be described and occasionally translated, and then we're working also on queries that surface the information, similar to the query I've shown you in the table for the people that are associated with Tel Aviv University. Okay, so that's what Wiki Project Medicine does on Wikidata. Now, let's go back. How does this look like in practice? So for instance, here we have a template, medical properties. Again, it's a table. This time this is handcrafted. This is not yet created based on a query, because actually the table is older than the ability to query Wikidata this way. In principle, we could create that on the basis of a query, but yeah, it already exists manually, so we've kept it. And here you see lots and lots of properties, many of which will be confusing initially. But for instance, if you are interested in anatomy, for instance, someone has a wound or something like this, then it might be relevant to annotate, okay, where was this wound? Was it at the head, at a toe, or somewhere else? And so here you have a mechanism to express that. So, you can think of a form field that fill in for your patient or something. But it's important to keep in mind here that Wikidata does not store information about individual people in terms of medical information, except things like cause of death or something, as long as there are public resources, like a newspaper article, so that have reported on this. But the idea is that you can express relationships like anatomical location of a lesion or so. And you can also express relationships to other databases, as I've already shown. You can express things like the prevalence of a certain disease, the route of administration of a drug, or for a chemical, you can express in which taxon it was found, and lots of other things. There are also some funny images here. So this one is actually called Squid. And what that does is it is a, let me just, so PubMed ID, for instance. Squid is a a visualization of the content that is relevant to that property. So here we have the property P698 for a PubMed identifier. So that's the identifier that a publication has in the PubMed database of medical literature. And Squid is one of the front ends to Wikidata that has information about such things. And so you see here that this property is used, 26 million times. And for instance, on these sample articles, it often goes together with things like page, issue, blah, blah, other identifiers you would expect for publications. And then there's lots more that you can learn about this particular property. So for instance, if you have an identifier, the PubMed identifier, then you can go to any of those URLs, you put it in as this variable, and then you get to that site as I've shown for the disease ontology earlier. Okay, so we have lots of those properties. Yes?
Can you actually show it to the students?
What?
What you just said, just taking that line and changing the end of it to...
Okay, so let's reload that. I'll just choose a random PubMed ID. And then I put in, let's say, 1, 2, 3, 5, 6, 4, 4, 3, whatever. Here we go. That's the article. It's really so simple, and the good thing is for Wikidata, it makes it simple to get to any such database as long as you know the identifier for that particular thing in that database. So in this case, it's that particular article. And actually, it's not. Yeah. So here is the identifier repeated. That's the thing that I used to get here. And then from here, PubMed also points to other databases, but I could go to Wikidata and it should have that entry as well. And so, well, we can actually check. So let's see.
Let's pause here for a second. I want to know if you're following what's happening on the screen. I know it's a lot. I know we've just encountered Wikidata, but what Daniel is basically showing you is that we have tools built upon Wikidata that are helping us curate information in interesting ways. So the first table that he showed us, all the people that are somehow connected to Tel Aviv University, that's a really interesting thing for us to be able to see. Some of the information that is missing, through that table, we can go to each of these items and we can add information in English, for instance. Why does it matter? Because it will help researchers, people from our university to be more visible to the rest of the world that doesn't know Hebrew, okay? Because some of it, as you saw, some of the names were in Hebrew, right? Do you follow what I'm saying? Okay, so such tools are helping us basically make the work that we do here at Tel Aviv University more visible to the world. And that's one of the projects that you can actually do in Wikidata, is taking these people and do a simple thing like translating the labels, like translating the names of the people to English to make it more visible. Another thing that Daniel is now showing you is that we can actually focus on specific properties, right, that have a relationship to medicine. And this is also allowing us to explore information in new ways that we couldn't before. You had a question? Or you were, no? Bana.
I just thought about it because he said that the people that we can see, like an example in Tel Aviv University, they are not historically, they are not named in a historically way, right? They are not in a spectrum of this, of who is the newest one you have added to this label. Yes?
Yes, not necessarily in this table, but we can do a different query that will show us a timeline, for instance, like we saw last time. Is that what you're asking?
Yes, but
okay.
what I was asking specifically is the number of people of the person. What does it apply about this person? Because he said that the number applies about the person's level or popularity or something. Because I did not completely understand that.
Okay, I can explain that. So in the query, we have here this line which says order by ascending ST. Ascending means from the smallest to the largest, and ST is here the number of statements. So if we go to the first one here, we see we have essentially 3 statements. This is an instance of a human, it's a male, and work location is Tel Aviv University. Boom, that's it. Not much more. But if we go to one of the others, I showed you some of the chess players. They had hundreds and hundreds of statements just about their chessiness. And then, of course, they had other things as well. So they're ordered by this number of statements. And in the query, maybe I have some limit. No, I have no limit. So this is the lowest one that we have. 3 is the minimum number of statements here. But in principle, you could have some item that only has something related to Tel Aviv University and doesn't say that it's a human or anything like that. But here, in practice, the lowest number we have is 3.
So what Daniel is saying again is through a table like this, you can help enrich the data that we have on people that are connected to Tel Aviv University, either by translating the labels, right, and adding description of who these people are. So it's very easy for people who go into this Wikidata item to understand who this person is, but also by adding statements about this person. What is the research they are doing? Where were they? When were they born? Etc. So like all the details that we, all the facts that we know about this person, we can add it to the Wikidata item.
So basically, the number is the number of statements we have about
Right.
the person. Okay,
Right.
I thought it was.
No, it's the number of statements, and it helps you then to see how much work you can focus on the items that need the most work, right? That has the least statements. So that's the idea. The idea is for us to have some kind of automated way to see things that it would have been very difficult to see otherwise, okay? And it's all done by a query, right? A short query that Daniel wrote, boom, gives us almost 3,000 lines of people from Tel Aviv University. Is it all the researchers from Tel Aviv University? No. It could be that some people are even missing from Wikidata, and I'm sure Daniel is going to touch it a bit later when he's going to talk about Wikisite. But yeah. Okay.
I also was interested in knowing how he put this information in the tables, because he said that he puts some kind of, let's say, one information, and it automatically made it for available for other people in this table. I did not completely understand how did he make that. He said
I can explain that. So I'm editing. There's the edit button on this table section on the page, and when I do this, some warning comes up, and then I see here something that looks like a template. So double parenthesis in the source code of a wiki page means there's a template, and this template goes until here when the double parentheses are closed. And this template basically is something that a bot, a computer program, is watching. So it is watching all the pages that have this template. And then here are the parameters. For the bot, initially, it doesn't matter what the parameters are. It just watches all the pages that use this template in general. Then, if any of those pages, it watches them in what sense? So it goes through that list of those pages that have the template, and then it actually looks at the parameters. One of the parameters is sparkle equals blah, blah, which is it's the same Sparkle query that we've seen live already. It will then execute the query. It will see what results it gets, and then it will check whether the results fit with what is here in the table. The table is replicated here, in not necessarily human readable way. So this is all the information about these researchers or TAU people. And so the bot compares the results it gets from the results of the query with what is in the table already. And if there is a change, it will make the change to the page. And we can see that by going to the version history of the page. And so here we see it's doing an edit roughly once a day. And sometimes the changes are major, like here 2,000 kilobytes, is, which probably means someone was curating some information. And here the information was reduced for some reason. Maybe some items got merged or something. But there is changes on an almost daily basis, which means there is active curation going on.
To simplify what Daniel is saying, we simply have a tool in Wikidata that is called Listeria. It helps us create this table. All we have to do is give it the query, like give us the details of all the people you know from Tel Aviv University, which is what Daniel showed you, and then telling it, I want to see these and these and these columns. So all the columns that you see in the tables, in the table that was generated, we can tell Listeria, the tool, which columns we actually want, okay, to be seen later on. And then what the book does is it, as Daniel explained, it will recheck and will update the table automatically, right? But all we need to tell it is the query and the columns that we want to see at the end. And you can basically, like everything else, you can copy someone else's Listeria list and you can change it to the query that you want with the columns that you want, and boom, you have a table that you wanted, okay? You have your own Listeria list that you can manage and work through, okay? Does that answer? Daniel?
Yeah, so I just highlighted here the line that does this specification of the columns. You basically just tell it number in the language that Wikidata understands. So everything has a number, and here the properties have numbers. And that means here the image, for instance, here, that would be P18, and so on. So you have to find out what the different properties, what their number is, then you put them into this command, and then the bot will do the rest for you. Okay.
More questions, Listeria? Okay. Daniel?
I'll close a few tabs.
Yeah.
And oh yeah, I wanted to show you that where was it? The article that we had looked at in PubMed. In PubMed, I had used this identifier, and in PubMed we had seen it that it also has a DOI, and then Wikidata also has a DOI for this particular article. And so you can use Wikidata to crosswalk between identifiers, because sometimes you have only a PubMed ID, sometimes you have only a DOI, sometimes you have something else, and Wikidata can facilitate the conversion between those articles or between those identifiers, so that it doesn't really matter whether you address the article via its PubMed ID or via its DOI, you will still be led to that particular article. Okay, so...
Can you say something to the students on why it's important to actually add the different numbers from different databases as identifiers? What's the use of it? I mean, we've talked about it, but it's another opportunity to kind of make that very, very clear to the students.
Science is about having a very precise language. So there is... the more you focus on certain, let's say, processes or systems, the more detail you know about them, the more precise vocabulary you need to express certain relationships or actions. So let's go, for instance, for stereochemistry. Lots of molecules are stereochemical, but for most people, it doesn't really matter that those molecules are stereochemical, which means that there is essentially a left-handed and a right-handed version of the molecule, and in most contexts it doesn't matter, and so they just refer to that by the generic name of that particular molecule. But if you're interested in stereochemistry, then you have to really distinguish between the left-handed and the right-handed, and between the mixtures of these. And so specific vocabulary has evolved in certain contexts that can make such distinctions. We saw the property like anatomical location before. If you have a thing like an eye, humans have eyes, many other animals have eyes, and then as long as you talk about the eyes in general, yes, their function is to receive light and to help the nervous system make sense of that light. But then the eye of a fly, the eye of a squid, and the eye of a human, they all do this in different fashions. And then if you want to discuss the differences between how a human and a squid and a fly process the light using their eyes, then you will need very specialized vocabulary. And the databases related to flies, humans, and squid will be different. And so if you want to crosswalk between those different databases, then you have to identify those things that are actually the same, which might be the overarching concept of an eye or of light reception, like this. And Wikidata can help you with that. And if you have, let's say, Wikidata entries for more specific things, let's say just the fly eye or fly, there are lots of flies in the world. If you want to be specific to the eye of, let's say, an early stage fly of a given species versus the later stage, then yeah, you need very specialized vocabulary. And Wikidata can help you basically, for instance, find databases that even have entry about fly eyes, anything like that.
Sounds good. Any questions about that? Awesome. So Daniel, can you maybe tell them about WikiSite, because our time is running really, really short.
Yeah, how much time do we have still?
That and Scholia, maybe?
Yeah, sure. Happy to. So just a bit of motivation. So we've seen those queries that we can craft by hand. Here is another one that I've just stumbled upon yesterday. It doesn't have much to do with medicine, but it orders the flags of countries by the number of colors in the flag. It's just another thing. We can do it because, well, we can do it. I don't have any particular, let's say, application for that. But these queries were handcrafted. You have to understand Sparkle in order to do this. And already Listeria showed you a way in order to basically make sense of that table of the TAU people. Once you see the table, you don't need to know Sparkle. You don't need to know Sparkle to look at that table, right? So you can look at that table, and what you would need to know is Hebrew or English and something like this. You don't need to know Sparkle. You need to know Sparkle to build the table, but not to read it or to browse the information contained in it. And with that same philosophy, we have a number of related mechanisms. So here Listeria is mentioned. If you want further information on Listeria, that's here. So we have a number of related mechanisms that allow us to basically make the process of using the information in Wikidata easier. One of them is Scholia. What that does is it provides us with profiles of things. And so let's just go there directly. My alarm clock is going up. I should wake up. Thank you very much. Yeah, it's still a bit early here. Here, this is the homepage of Scholia, and then you have lots of things, a search thing. We don't have too much time, so let's jump in right into one of the examples. The Zika virus is one of my favorite examples. We also have lots of statistics here, which might be interesting for you at some point. So here, the Zika virus is a concept. It links to the Wikidata entry for that particular virus. It also links to the English Wikipedia article. And then it has a number of sections. We don't have too much time, so I'll just point out some of them. Here, an Rss feed. So if you are interested in most recent publications on that particular topic, you click on that and you put that into your RSS reader. Then publications per year, you notice, oh yeah, the thing was discovered in 1952, then there's like 60 years of nothing, then there was the public health emergency in 2016, suddenly the topic exploded, more than 1,000 publications in a year, and now it's going back to normal. You have things like the authors who publish about the topic. That's something that you don't easily get from places like PubMed or so. You see relationships between the authors, and all of that is based on queries. So I can, for instance, click here. Each of these queries comes with a link here. I click on the link, and then this leads me to that particular Sparkle query that has produced that graphic, and then I can edit that in order to adapt it to whatever I need. We have topics. So this page here is created by annotating the items about the publications with the property main subject. So here's an example work, which basically means this work is about the Zika virus, but it's also about the Zika virus infection. Many works are combining different topics. And so here you can see how often do different topics occur together with the Zika virus. Of course, the Zika virus infection is on top here because, well, if the virus wouldn't infect people or mosquitoes, then we wouldn't talk about it very much. And then there's other topics that co-occur with it. You can visualize the relationships between those topics. You can, some of them also have a geolocation, so you can plot them on a map. And for each of these things, let's see what's here. Zika virus disease in traveler returning from Vietnam to Israel. So that's, and then of course I can click on any of that. We can rank the authors by taking into account not just how much they've published, but also how much they've been cited. We can identify the journals that publish on that particular topic and rank them by the number of articles they've published on that topic of the Zika virus. We can identify the most cited works on the topic. We can identify the most cited authors amongst those who have published on the topic. We get awards that people have received who have published on a topic. Yeah, so, and also importantly, at some point there should be, where is it? Well, there's an easy way to get to the gaps. So by just appending /missing to the URL of that page, you see we have a number of things that are missing in the database, so that we know that are missing. Of course, we also have things that we don't know that we're missing. But here, for instance, we have an author name string. So we have a number of publications for which an author name string like this appears, and we don't know which author this actually is. And then we have tools that help us map this. Here, I just mentioned a tool. We don't have the time for details, but the point is that Scholia can help us visualize gaps that we have in the knowledge. In terms of the identifiers, here, for instance, if you have an identifier like a DOI, you can call Scholia /DOI and then whatever that DOI is, and it will then redirect you to the profile for that particular article. Or if you have an identifier for a person, you can call Scholia /toolkit /that identifier, and then you will be led to the Scholia profile for that person, and so on. Even it works with Twitter. So if you have a Scholia identifier for the Twitter identifier for someone, you can call Scholia /Twitter /their Twitter name, and then you get the Scholia profile for that person. And yeah, so that's the basic idea for Scholia. It really hides the complexity of writing Sparkle queries. It means that if you want to see it, you can always see it. You look at this one that created this table here. But if you don't want to engage in creating Sparkle queries, you can just use the tool as it is. So you type anything into the search, and then Wikidata or Scholia will show you what content it has. It only shows you content from Wikidata, with the exception of this top thing here, which is from Wikipedia. And so as long as Wikidata is incomplete, the Scholia will show you incomplete information. Importantly, all the code for the tool is public domain. And so you can go there, contribute to the code directly, or if there's a problem, you can leave a note there on the issues. So yeah, that's a quick run through Scholia. It can also do things like comparisons, or it has combined views. For instance, here we have, if you want to know publications by University of Costa Rica and about snake bites, then we can see those here. These are severe snake bite, blah, blah, a number of publications just by that particular university and about that particular topic. And that can be adapted. So if you know, for instance, Tel Aviv University, you change that identifier, and you want to change the topic, you change that identifier. You can compare things of the same kind. So for instance, here we have three people here. You can look at how they compare in a number of ways, or which works they have co-authored, things like that. Yeah, so that's an introduction to Scholia. We have a page on Wikidata which is called Wikidata Scholia. Not very easy to see here, but it's linked on here. And also clinical trials, for instance. So Scholia can visualize clinical trials. Let me show that at least. And so on the project here, clinical trials. It has overview stats for the different phases of clinical trials, for instance. And then it can give you the most recent clinical trials. Interestingly, many of them start in about 100 years, 80 years. That's because of problems in the databases from which Wikidata is getting this information. You can identify clinical trials. The most common topic of clinical trials seems to be diabetes mellitus. Then, like, what are the most common interventions, things like that. All of that, you see, we have about 300,000 clinical trials indexed. Last year when I gave this talk, we had less than 1,000. So there is active development in this area. And Scholia is one of a number of initiatives within Wikisite, which tries to bring together the reference information so that it is easier to reference things in Wikidata, but also in the long run in Wikipedia and elsewhere. Because if you want to add a reference for a claim in Wikidata, then it's not that easy because Wikidata needs structured information, and Wikisite basically structures that information for typical references for you, so that you then just refer to the Wikidata item about that particular reference that you want to cite.
This is awesome, and I just want to stress and make sure that you understand the vastness of this tool and the coolness of it. I mean, as future researchers, usually what you use is Google, right? You search for something and you'll get thousands and thousands of websites that might, have the word that you're looking for in the results. But this is actually, tools like Scholia actually give you exact details, and it generates automatically so many cool things, and you can visualize all the information when you do a research around a specific topic. So this is changing the way we actually do research. This is basically helping us save hundreds and hundreds of hours of manual research that we used to need to do manually before we had tools like that. So I'm hoping you understand, first of all, that, hey, that's really cool. B, I want you to be aware that it exists, because in a few years from now, you're now in first year, but in 3-4 years, you'll need to do a research project as part of your MD. And, this is one of the tools that you'll be able to use. So I just wanted you to be aware that such tools exist and that Wikidata is actually changing the way that we can do research. And yeah, just try to explore it. I know, again, I understand it's a lot. I know it's very different from what you're used to, but for your Wikipedia articles, you actually had a chance to take a look at Google Scholar. right? Some of you looked for information and maybe PubMed. So you can start to understand why what we've just seen is such a game changer, because suddenly when I look for a topic, I can see all of these different details and I can really look into it and search it in ways that weren't possible before and that Google Scholar is not allowing us to do. So yeah, Daniel, thanks so much for showing it.
Can I say two more things?
Yes, please.
So here I prepared a query for people in Israel who work on diabetes type 1, for instance. You can look at that. And another tool similar to Scholia that gives you information about languages. The same idea. You hide the complexity of the Sparker queries, but you show the results of them. And so here you can explore, for instance, the Hebrew as a language. Right now we have mostly nouns and verbs and a few adjectives, but you can think about adverbs or any other interjections, bring those into Wikidata, and then you can do the same thing with language that we're doing with scholarly materials. And so that's just the beginning of making the semantic web experienceable by people from all walks of life, be they medicine or linguists or whatever.
Awesome. Questions for Daniel before we move on to the next section of our session today? This is a huge opportunity. So take a chance and ask something. It doesn't have to be, big, but you have a chance to talk to actually one of the leading people in the world to be doing this. So any questions at all? Don't be shy.
And if you're wondering, like, okay, this is overwhelming, how can I get started? I put in a list of things, potential activities related to the course, where you can just browse them. And there's a link here, activities. These are things that other people found useful to enter this space of Wikidata.
Awesome. And on that optimistic note, I want to thank so much Daniel for joining us so early in the morning. What time is it on your end of the world?
7:18.
Oh my gosh, I can't even imagine. Thank you so much for waking up so early to talk to us. And I do hope that anyone watching and of course you, dear students, now have a bit of a taste of the power of Wikidata and what it can do for us in research and in understanding the world around us and exploring information. So Daniel, thanks again for joining us, and I'll see you on Wiki.
Yeah, cheers.
Cheers, bye. Okay.